We are going to title this Systems Method 1 Graphing. We started this graphing method before break. This one that we're dealing with in this problem is actually different than what we were talking about before break. And I'm going to show you how I use the graphing to solve it. And then we'll also make sure we talk about that idea of substitution as a method to solve as well. So let me just walk you through how I would solve it. And then what was I going to say? Oh, and so you will have homework today. It's going to be 2 problems, kind of like this one. But I want you to be able to use a graphing method as one of your methods. Okay? So I began by writing down what I knew, kind of what you guys were doing too. We knew that the boxes and bags, we knew that we had 100 of them. So the boxes and bags total was 100. And so we wanted to find out how many of each, right? Like whether 25 and 75, 20 and 80, we wanted to know how many of each do we have. We also learned, and the wording here is important, we learned that there was 1/4 as many bags than boxes. And that keyword there, as many, that's a hint for our equation that we're going to be creating. That might mean usually like multiplication or division. And this up here, total, that makes me think like addition. And Ishan, thank you for your idea. That's a really important thing here. It says there's bags and boxes. And so I want to ask myself, well, what do we have more of? We have 1/4 as many bags than boxes. That means we're going to have more boxes, right? So I need to make sure in my answer, I get to an answer where it shows I have more boxes than I have bags because of that thing going on there. Now, writing down what I knew leads me to my variables. And in this case, the one thing we want to know is how many boxes. So I might just call that my x. My x is the number of boxes that we collected. The other thing we don't know is bags, so let's just call that y. Y is the number of bags we collected. And so some people wonder, well, how do you come up with the equation? And that's an important thing, but that's not our purpose today. Our purpose isn't to be able to create equations for these. Our purpose is to be able to solve equations, to be able to solve a system. But here's how I come up with the equation is, well, I look at what I know. The bags and boxes total 100, so that means we add them together. X plus y need to equal 100. And that alone leads us to a lot of different possibilities. It doesn't lead us to one answer. So that's a hint that actually there should be another equation as well, because that alone is not enough to get to one answer. So that leads me to this other one. Okay, so let me think. 1/4 as many bags. So I'm thinking some sort of like multiplication here. But I'm gonna have more boxes. So I'm thinking if I take my boxes and I multiply it by 1/4, that'll tell me how many bags. So something like that. Now, some of you think about it the other way, and actually I saw it come up in your examples. You wrote it as like this. You might say like 4 times the bags is the boxes. That would work too. Both of these show the same thing. Right? And this one, I think, would be really good for substitution. Because if x is 4y, then really what we have is 4y plus another y has to equal 100. And so some of you can solve it that way. And Ishan, you just have to change, you put an x in there, you have to put a y. Because I said my y's were bags, and so it has to be 4 times y, not 4 times x. If you're going to use the x, you have to do 1/4. Yeah, no problem. It's just an important thing to point out. But yeah, I'm not going to use this one today. I want to show you how to solve with graphing. And so I'm going to leave it like this because, hey, that slope-intercept form, we know how to graph slope-intercept form. And then what's this form called? Do you remember?
Standard form.
Standard. We know it's standard because the variables are on one side and there's a number all by itself over here. So we have our two equations. We're going to graph them to see our possible answers. And to graph, make a table. We're going to make a table over here, and we're going to make a table over here. And if we find two ordered pairs, then all we have to do is connect them and draw our line. And this is the method I want you to use on the homework today, is you're going to get some that are in standard form and some that are in slope-intercept. I want you to be able to graph them and see where your solution is, okay? So let's always start by finding out what's our y-intercept. Well, let's see. That happens when x is 0. This slope-intercept is nice. The y-intercept comes at the end, but it's not there. That means my y-intercept is 0. Over here, I have to treat it like a function. I have to plug in the 0. So this is 0. 0 plus something is 100. That means my y is 100. So I have my y-intercepts for both. And as I'm going, let me know if you have questions. You could. Yep, Mahi, you could. You could substitute the you could substitute this in for your y, and you'd have x plus 1/4 x equals 100. And that would be a substitution method to solve. Yep. Yeah, it would help solve. It'd be another method. I don't like that one, though, just because you have to deal with the fraction. So let's continue this one. Now I need to choose one more ordered pair. I can choose whatever I want for my x. I could do a 1, a 2, a 3. But here's a tip, though. If it's in standard form, let's find out what the x-intercept is. If y was 0, we'd have x plus 0 equals 100. That means this would be 100. You don't have to do it that way. You can choose whatever number you want. It's just sometimes with standard form, as long as you get nice whole numbers, that's a good way to do it. Over here, slope-intercept, I could try a 1, a 2, a 3, but all those are going to give me fractions. So let me try a 4. If x was 4, well, 1/4 times 4 would be 1. That's nice. Now I'm ready to graph. I'm not going to have any negative boxes and bags, so when I draw my coordinate plane, I don't need to worry too much about the negative quadrants. So I'm going to be mostly in that first quadrant in that top right corner. So what I'm thinking is I'm going to probably change the scale to fit the 100 on there. So I might go kind of like 10 by 10. That's what I'm thinking, 10 by 10 and maybe just a little bit in the negatives. So let me count that down and draw that out. So here's my y-axis. There's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you know what? Let me just I'll go 5 into the negatives just so that it's there. 1, 2, 3, 4, 5, like that. You know what? We said x was boxes, so let me just write boxes down here. And y was bags, so I'm going to write bags over here. And then to fit the standard form on the graph, I need to put 100 up here at the top. So that means all of my grid marks are going by tens. So let's see, if I go halfway, it'd be at 50. So there's 10, 20, 30, 40. Here's my 50. And we're going to keep it the same down here on the other axis so that I can graph the x-intercept too. 100 boxes are out here. And then 1, 2, 3, 4, 5. Here would be the 50. And now we graph. We use the table to help us graph. The y-intercept is 100. So there's going to be a line that connects to the 100 up here, and then a line that connects to the 100 down here. This is my standard form. And everywhere on this line is the possible combinations that add up to 100, like 90 and 10, 20 and 80, 25 and 75. Do you see how I graph that standard form?
Yeah. Could you go over it again one more time, please?
Yeah. I had my equation. I found my y-intercept, and then I found my x-intercept, and then I graphed them. 0, 100 is up here, 0, 100, and then 100, 0 is right here. I'm noticing something for my next one, though. When I graph it here, 0, 0 is going to be the origin, so that's right there where all the axes meet. It's going to be too tough for me to graph 4, 1, though. It's not going to be very accurate. So I'm thinking, let me choose a number that's easier to graph that comes out to a nice integer. Ooh, 40. Let me try a 40 in my table. If x was 40, then I'd go 40 divided by 4 and I'd get a 10. I can graph 40, 10 a lot easier than I can graph 4, 1. So I'm going to graph this one instead. X is 40, so go out to 40. Y is 10, so I go up 1. There we go. And now we find out where they meet. Ooh, I can already see it as I line up my ruler. They're going to meet right there. Now here's a tip. Make sure you draw your lines nice and long so they extend out and you can see where they actually meet. And then the x would be, let's see, 60, 70, 80. And the y is 20. That's how I got to my answer. So we collected 80 boxes and 20 bags. Some of you had other methods to solve this system. That's great. Keep them. You will want them. But also today in your homework, I want you to practice this method because this is going to be another tool you can use on problems like this. Yeah, a question about the second line. So it came from the slope-intercept. And since it's slope-intercept, I said, okay, what's my y-intercept? That'd be 0, so 0, 0. And then I just needed another point. So I was going to try 4, 1. But the thing is that wasn't going to graph very easily. So I just did another one. And I looked at my graph. I said, you know what? 40 would be easy to graph. So that'd be 40, 10. And so I graphed the 0, 0, the 40, 10, and then drew the line to connect them. And that's how I got to my answer. So this is kind of like what we did before, but it's different because these equations aren't the same form. You can run into a lot of different forms of equations. Any other questions, comments, concerns, wonderings? Okay. Let's go back to the Desmos. We'll do a little bit of reflection on slide 6. This is the last graphing method we're going to talk about. We will focus on the non-graphing methods on Thursday.